The very last thing we'll look at is something called the transformer. So you may remember from in the previous unit in circuits is that over long distances we discovered it's better to transport electricity at high voltage instead of really low voltage. So basically you need a way of stepping up that voltage. And when you get back to town, we need to drop it down to a usable voltage of around 120 volts for our homes. Again, as it's traveling, it has huge potential. That's why we always say stay away from fallen power lines, because the potential is so great that if you touch it, it's just going to create this huge current through your body and most likely kill you. But from a money side of things, we need to be able to ramp up or ramp down the voltage. I did read, I can't remember where I read it, but apparently they have ways of transporting electricity at lower voltage now, but because the infrastructure is already in place, it's not really economical to change things out. But again, I'd have to do a bit more reading on that, but I've heard it is out there, the technology. How a transformer works is you get like a metal core that's in the form of a loop. I'm just going to draw a square loop. This is like some metal core. Okay, and what this metal core is now, it kind of acts as a guide for magnetic field. So let's say we have some voltage on one side. So we have some circuit, and we loop that wire around this left side of this coil. So we have some V in. So we call this the primary side. So V in, or V primary. We have some current primary in, and number of turns. And the number of turns, well, in this case you can see in this drawing they did 1, 2, 3, 4, like 5 turns. And this we call the secondary side. So basically what's going to happen is if we send alternating AC current through here, we're going to have a changing current which is going to create a magnetic field, and then this magnetic field is going to travel along this guide. So the magnetic field is going to just be guided through this core. So this one creates the magnetic field, and then the magnetic field passes through this other side, which will have a different, like for example, if we have more loops on this side. When we talk about loops, like even when I drew 5, when we use like when they actually have transformers, they have like thousands, tens of thousands, hundreds of thousands, like thousands and thousands of loops to really get the voltage high or low. So we call this so this is outside, so we have the secondary, VS, IS, NS, and so on. So by sending in some current on this side, creates a magnetic field, which interacts with this coil and outputs a different current voltage. That's basically how a transformer works. So you can either step up or you can step down. So if it's going in from small to many coils, that's stepping up. Going from many coils to few coils, it's stepping down. So our equations are basically following a step up. So the secondary coil has more turns. Step down, secondary coil has fewer turns. So how do we measure the change in voltage? So we just have some equation. We know V is equal to N times the change in flux over T. But basically if we equate the two equations, the key idea for this one is that we know the magnetic field is constant. It's a single core, and the magnetic field here is the same as the magnetic field over here as it's traveling around. So that's constant. So if we substitute one equation to the other, the secondary with the primary, just do a little bit of math, we get the following expression. Vs over Ns is equal to Vp over Np. And using Ohm's law, we can also find the relationship between current as well. We get Vs Is equal to Vp Ip. And it's as simple as that. If you know the voltage, if you know the number of turns on either side and know one of the voltages, you can find the other voltage. And same for current. One thing to note is that power is conserved. They're very efficient, these transformers, so power is conserved. So basically, we can see here that if the voltage is high for secondary, the current will be low, but then if the voltage is low, the current has to be high. So there's always this trade-off. Doing high current, low voltage or low voltage high current.